In this next section of the course, we'll be investigating light and how it affects things like global warming. But to start off with, we have to have an understanding of light itself. And one of the things that we're going to be talking about over the next couple of lessons is an idea of a black body. And black bodies are very important for an understanding of how light from the sun is reaching Earth and how it's affected by things like temperature, etc. So, what is a black body? Well, a black body is basically defined as anything where all of the radiation, all of the light that strikes the black body is absorbed. So no light is reflected. So this body is absorbing all of this radiation. And that means that any light it gives off, any emitted radiation, is only due to its temperature. And the light from a black body gives a very specific intensity graph, and we can see that here. This is known as a black body curve, and you can see that the intensity starts to increase at very short wavelengths quite quickly, reaches a peak and then drops off slowly into the longer wavelengths. So these are the high energy photons, these are the lower energy photons, and what we can see here is a very distinctive peak, and we know that call this a black body curve. So there are not many objects around that give perfect black bodies, but the sun is an example of something that's quite a good black body. So here's the sun, and this is the radiation curve, the black body curve for the sun, and you can see that you have a black body curve on the red line and the sun's here, and there are a few discrepancies, but generally it follows the curve pretty well. And you can see that the peak here is in the kind of green between blue and yellow, so around about 500 nanometers is where the peak is. The other thing to notice is that black body curve, the peak of a black body curve does move as the temperature of the black body increases. So this is a black body at about 3000 Kelvin, and the peak is right down here in the infrared. Here is a black body similar to the sun, as we were just looking at, and the peak is here in the middle of the visible spectrum. And here is a black body for a very hot star, for example, at 10,000 Kelvin surface temperature, and the peak is right up here. So as the temperature increases on a black body, the peak of the black body moves from the right-hand side of the graph to the left-hand. And what you're finding is that you've got more photons released, so the intensity is higher, but also the photons have more energy.